Hello students. So in the previous class we have discussed about the topics which we are going to learn for exercise 2.2. So let us do some problems, questions which are there in exercise 2.2. We'll start with the first question. The first question is the set A is having elements 1, 2, 3, 4 up to 14. Now you have to define relation from A to A. But the relation is given as having ordered pairs x and y such that 3x minus y equal to 0. And both x and y are from A only. So first of all, x, you will take x from A. That means x you will take 1, 2, 3, 4, 5 until 14. And then y. From this relation, y will be equal to 3x. That means the y's will be when x is 1, 3. When x is 2, 6. When x is 3, 9. When x is 4, 12. When x is 5, 15. But you can't take 15 because 15 is not in set A. So you can take only these xy's in the relation. When x is 1, y is 3. When x is 2, y is 6. When x is 3, y is 9. When x is 4, y is 12. So this is how you can make the relation. Now they are asking you to write the domain. Domain means you will write all the x's 1, 2, 3, 4 as a set. So this is the domain of the relation. Range. Range means you will write all the y's which are there here. So you will write 3, 6, 9, 12. The next is codomain. But codomain you will write all the elements in A, this set A. That means you will write 1, 2, 3, 4, so on up to 14. Okay, let us go to second question. I will try to erase this one. But it is not accepting. Okay, we'll go to the next page. Let us take second question. The relation R is defined on the set of natural numbers. That means natural numbers to natural numbers. And R is given as ordered pairs x and y such that y is equal to x plus 5. And then they said x is a natural number, y is a natural number. Apart from that, they said x is less than 4. This is the condition. You have to write the relation in roster form, domain, and range. So first of all, the values of x you can take are natural numbers less than 4. 1, 2, 3. Then for y, you have to take the relation x plus 5. So when x is 1, y is 6. When x is 2, y is 7. When x is 3, y is 8. That means you will write the relation as x1, y6, x2, y7, x3, y8. And now this is in roster form. The domain will be set of all x's. Range will be set of all y's. And codomain will be set of natural numbers. This set of natural numbers. Okay. We can go to question 3. In question 3, set A is 1, 2, 3, and 5. 1, 2, 3, 5. Set B is 4, 6, 9. You have to define relation from A to B. R is such that it has ordered pairs X and Y, such that the difference between X and Y is odd. Why did I take difference between X and Y like this? Because it can be X minus Y or Y minus X, anything. The difference must be 3. Sorry. It can be X minus Y or Y minus X, but the difference must be odd. And then it is given X is taken from A, Y is taken from B. Maintaining all these, we have to make the relation. Okay, so how will you take X and Y? So I will make X and Y one column. 1 minus 4. 4 minus 1 will be 3, which is odd number. Then 1 minus 6 or 6 minus 1, 5. It is an odd number. Then 1 minus 9 you can't take because it will be even number. Next, 2 minus 4 or 4 minus 2 you can't take. It is even number. 2 minus 6 or 6 minus 2 you can't take. Then 2 minus 9 you can take, or 9 minus 2 you can take, because the difference is odd number. 3 minus 4 or 4 minus 3 you can take because the difference is 1. Then 3 minus 6 you can take, or 6 minus 3 because the difference is 3. 3 minus 9 is an odd number. You can't, it's an even number. You can't take. 5 minus 4 or 4 minus 5 you can take because it's an odd number. 5 minus 6 or 6 minus 5 you can take, it's an odd number. 5 minus 9 or 9 minus 5 you can't take because it's an even number. So what all are included in the relation? 1 comma 4, 4 comma 1. This is included in the relation. Isn't it? But we need not write twice. If you write once, it is enough. So I will remove 4 comma 1. Next, I can include 1 comma 6. I can include 2 comma 9, 3 comma 4, 3 comma 6, 5 comma 4, 5 comma 6. Now 1 comma 4 I wrote, but 4 comma 1 I did not write. That is because X should be from A, but in A you don't have 4. That's why you have to see properly which all you can write, which all you can't write. 1 comma 4 you can write, but 4 comma 1 you can't write. Okay, so now the domain is the set of all X's. We have taken 1, 2, 3, and 5. Range is set of all Y's. It's 4, 6, 9. Codomain. For codomain, you will write the set B, complete set B. That is 4, 6, 9. Here you can see range and codomain are same. That is an important point to be observed. Okay, fourth. Question number 4, I will first give you an arrow diagram. In the circle or in the set P, I have 5, 6, 7. There is another set Q in which the numbers are 3, 4, 5. 5 is joined to 3, 6 is joined to 4, and 7 is joined to 5. So this relation is from P to Q. Now you have to write the relation in set builder form, roster form. Writing in set builder form is slightly difficult, but writing in roster form is easy. 5 is joined to 3, 6 is joined to 4, 7 is joined to 5. Now see the relation. What is the relation between 5 and 3, 6 and 4, 7 and 5? 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 5 is 2. So with this we can write in set builder form, R will have ordered pairs x and y such that x minus y will be 2. And then x is taken from P, y is taken from Q. Now domain will be all the x's which are matched, 5, 6, 7. Range will be all the y's which are matched, 3, 4, 5. Coming to codomain, codomain is nothing but the set Q. In set Q, we have 3, 4, 5. Here again, you can see in this problem also, range and codomain are exactly same. Let's go to question number 5. A is the set having 1, 2, 3, 4, 5, 6. R is a relation defined on A. That means from A to A. There is no other B. And R is given as the ordered pairs A comma B, where A, B both such that A, B both are taken from the set A and B is exactly divisible by A. What do you mean by B is exactly divisible by A? B is multiple of A. That is what it means. So when you write the ordered pairs, if you take A and B should be multiple of A. So suppose if you take A as 1, 1 times 1, you can take 1. 2, multiply 1 with 2. 2 times 1. 3 times 1. 4 times 1. 5 times 1. 6 times 1. 7 times you can't take because 7 is not there in the set. So when A is 1, you can take all these. Now when A is 2, 2 times 1, 2. 2 times 2, 2 times 3. Only until here you can take. Next, when you take 3, 3 times 1, 3 times 2. Only until 6 you can take. If you take 4, 4 times 1 you can take. 4 times 2 you can't take. For 5, 5 times 1 you can take. For 6, 6 times 1 you can take. So all these ordered pairs are included in the relation. So that means 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 you can take. Coming to 2, you can take 2, 2, 2, 4, 2, 6. With 3, 3, 3, 3, 6. 4, 4, 4, 5, 5, 5, 6, 6, 6. Now domain, all the x's which we have taken, 1, 2, 3, 4, 5, 6. Range, all the y's which we got, 1, 2, 3, 4, 5, 6. Codomain, codomain is the set A itself, this set A. So in the set A, 1, 2, 3, 4, 5, 6. Again, here also you can see range is same as codomain. Let's go to question number 6. You have to find the domain and range of the relation given as x comma x plus 5, the ordered pair, where x belongs to 0, 1, 2, 3, 4, 5. So to find domain and range, we must know what is the relation, what are the ordered pairs. X you will take 0, x plus 5, 0 plus 5. X is 1, 1 plus 5. X is 2, 2 plus 5. X is 3, 3 plus 5. X is 4, 4 plus 5. X is 5, 5 plus 5. This is the relation. So now you can write what is the domain, all the x's which are matched. 0, 1, 2, 3, 4, 5. What is the range? All the y's which are obtained. 5, 6, 7, 8, 9, 10. We don't know what is the codomain. So here we can't write what is the codomain. Question number 7. The relation R is given by ordered pairs x comma x cube such that x is a prime number less than 10. You have to write it in roster form. So x we will take prime number. 1 you can't take because 1 is neither prime nor composite. X we will take 2. So x cube, 2 cube, 8. X we will take 3. 3 cube, 27. 4 is not a prime. 5 is not a prime. 6 is not a prime. 7 is a prime. 7 cube. 7 square is 49. Multiply with 7 again. So it is 343. 8 is not a prime. 9 is not a prime. So you have to take prime numbers less than 10. So that is what they have asked. They did not ask anything domain, range, codomain. Just they asked you to write in roster form. 8th question. A is the set having elements x, y, z. And B is the set having elements 1, 2. You have to find number of relations from A to B. So n of A is 3. N of B is 2. So n of A cross B will be 3 into 2, that is 6. Now, number of relations R will be 2 power 6, that is 64. Question number 9. R is a relation on Z. That means R is a relation from Z to Z. R is given as ordered pairs A comma B such that A and B both belong to Z. And A minus B is an integer. Find the domain and range. Because A is taken from integers, X is taken from integers, the domain will be set of integers. Now the range B is also belonging to integers. So range is also set of integers. It's very clear. So with this, we have completed exercise 2.2 successfully. Now, to go with 2.3, you have to learn some more concepts. After learning concepts, we can move on to exercise 2.3. And this is the last exercise we have here. So now, the concepts for exercise 2.3 mainly is to study about functions. Last class, we have learned about relations. Now, functions. What are functions? Actually, if you know relations, you can understand functions. Function is nothing but relation. Function is a relation itself. That means all functions are called as relations only. But a relation, sometimes it is a function, sometimes it is not a function. That means all relations are not functions. Only a few relations are functions. First, I will show you one example and I will tell you whether it is a function or not. Suppose in a relation, you have 1 is matched to 2, 1 comma 2, 1 comma 3, then 2 comma 4, 2 comma 5, something like this you will have. Then this relation is not a function. Why this relation is not a function? Because the x, that is 1, it is coming 2 times. Okay, if you see this x is also coming 2 times. That means it is not a function. If the x repeats again and again, it is not a function. Suppose if I say, okay, I will repeat 1 comma 2, 1 comma 3, But 2 I will not repeat. 2 comma 4, 3 comma 5. Even then it is not a function because this x is repeating twice. That's why it is not a function. Similarly, in arrow diagram also I will show you. This is a set, this is another set. Here we have 1, 2. Here we have 2, 3, 4, 5. If 1 is joined to 2 as well as 3, 1x is matched to 2y's, then it is not a function. Suppose if I match 2 to 4 and 2 to 5, again 1x is matched to 2y's. So this is not a function. Suppose if I say, okay, I will take 1, 2. I will take 2, 3, 4, 5. 1 I will match to 2. 1 I match to 3. Here itself you can see 1x is matched to 2y's. So immediately I will say it is not a function. Suppose if 2 is matched to 4 and 3 is matched to 5, then also here 1x is matched to 2y's. That's why it is not a function. So in short, what I can say is x should be matched to only one y. X should not be matched to y1 and y2. If x is matched to y1 and y2, it is not a function. A single x should be matched to single y. 1x matched to 1y. Then only you can call it as a function. This is an important rule for a relation to be called as function. But this is not sufficient. There is one more rule. What is that rule? Suppose A is having 1, 2 and B set is having A, B, C. Or I will take B set is having only A. Now if I write the relation, 1 is matched to A. And if I write 2 is matched to A, that's okay. But if I don't write this, if I won't write 2 is matched to A, I'll just write 1 is matched to A and leave it. Then what is happening? I have matched 1, but I left 2. R is a relation from A to B. In the set A, I have taken 1, but I have left 2. I did not take 2. That's why it is not a function. Suppose if I take 1 comma A and 2 comma A, from the set A I have taken 1 and 2. Every x I have taken. This x I have taken, this x I have taken. Then I can say this is a function. Now you may ask me, A is repeating. How can I call this as a function? Y's can repeat. The rule is only for x. I said 1x to 1y. That means X should not repeat, Y can repeat. Like if you have X comma Y1, X1 comma Y1 and X2 comma Y1, then it will be a function. I said Y's can repeat. But if X repeats X1 comma Y1, X1 comma Y2, X is repeating, it is not a function. This you have to keep in mind. X can repeat, but Y can repeat. X cannot repeat, Y cannot repeat. Don't get confused with this. You have to see X should not repeat. Y, it may repeat or it may not repeat. No rule for Y. The rule is for only for X. In the same way, what is the other root? All X's must be taken. No X should be left. X equal to 1, X equal to 2. All the X's must be taken. But there is no rule for Y's. Y's may be taken, Y's may not be taken. So for a relation to be a function, the rule is only for X. Whatever two rules I told you, they are only for X. First one is all X's must be taken and X should not repeat. Y's, if you want, you take. If you want, you leave it. Nothing will happen. Similarly, Y's, if you want, you repeat. Y's, if you don't want, don't repeat. So in short, the rule is if a relation is from A to B, A is called domain of the relation, B is called codomain of the relation. So X is taken from the domain, Y is in the codomain. So the first rule is all X's from A must have Y in B. That is the first rule. What is the second rule? All X's which are taken from A must have a unique Y in B. Unique means one and only one. Unique means one and only one. Suppose if you take X as 1, it must have only one Y, 4. One cannot have another Y, only one Y. So this is what I mean, the two rules. But the two rules, if satisfied, you can call the relation R is a function. So I will combine the rule and I will state like this. A relation R is a function from A to B if every element of set A has one and only one image in set B. Both I have combined. What I'm saying, all X must be taken. That's why I'm telling every element of set A. Then if you take every element of set A, it should have only one and only Y. One and only one Y. Image means Y. I told you in relation, if X comma Y is there, Y is called image of X and X is called pre-image of Y. I told you this. So there is another way of saying, instead of relation R, I can represent the function by F. So F is a function from A to B. If for all X belonging to A, there exists a unique Y in B. Domain of this function, domain of F is the set A. Codomain of function is set B. And the range is nothing but all the Y's which we get. Range is nothing but the Y's which we are getting. So in the function, you will have ordered pairs X and Y. The function is nothing but ordered pair X and Y. So what I can say is, if you have X in the set A, Y will be there in set B. To get Y, you need some equation. Y will be f of X. The equation will be called as f of X, the equation. Why, I will tell you later. So at present, you need not concentrate on this part. Just concentrate. Function means it is set of ordered pairs. And to make ordered pairs, remember such that X belongs to A, Y belongs to B. But that is not enough. For all X belonging to A, there exist. Instead of writing for all again and again, in maths there is a symbol. Instead of writing for all, it is like a big sentence. You can write for all. The meaning of this is for all X. In A, you are taking all the X's. There exist. The meaning of this is there exist. Instead of writing there exist, I'll write this. There exists a unique, single, one and only one Y in B. This is how you can define the function in set builder form. Remember, X is pre-image of Y. Y is image of X. If you did not understand now, go through these notes again and again. Remember these terms, because from next time onwards, I will not explain you in simple words. I will use these terms only. Let's take one example. You know, n is set of natural numbers. Suppose R is a relation defined on n. That means R is a relation from n to n. R is a relation from n to n, such that R is given as ordered pairs x comma y is equal to 2x. X and y both are taken from natural numbers. So, there, if you have to find the domain, codomain, range, and is this relation a function or not? Now, how will you write it? I will make two columns for x and y. Or directly, I will write the ordered pairs now, because now you are good, very good in writing the relation. Why to waste time? I will write the relation. X, I will take natural number 1. If I put x in this equation, I will get y. Y is 2 times 1. 2 into 1. If x is 2, y is 2 into 2. If x is 3, y is 2 into 3. If x is 4, y is 2 into 4. Like that, it moves on. So if you see domain, x's, we are taking all natural numbers. I have just taken 1, 2, 3, 4. I will take all natural numbers. And if you see range, the y's which we are getting, what are the y's we are getting? The range, we are getting 2, 4, 6, 8, so on. So we are getting just even natural numbers in the range. But what is codomain? Codomain is the set of natural numbers. 1, 2, 3, 4, so on. It's the set of natural numbers. Now, is this relation a function or not? First of all, this is domain. Domain is natural numbers. Codomain is natural numbers. So I am saying that it is a function. This relation is a function. Why it is a function? Because from the domain, I am taking all natural numbers. I am taking 1, 2, 3, 4. I did not leave any natural numbers. Like that, I'll take all. So all x's are taken. Coming to the second condition, no x is repeating. No x is repeating, isn't it? That is why it is a function. Two conditions are enough. Okay, another example. Suppose I will give you the relation 2, 1, 3, 1, 4, 2. Suppose I'll give you the relation 2, 2, 2, 4, 3, 3, 4, 4. Suppose I'll give you the relation 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. I'm giving you three sort of relations. You have to say whether these relations are functions or not. So first of all, domain, all the x's 2, 3, 4. So I have taken all the x's 2, 3, 4. I did not leave anything. And then these x's are not repeating. So I can say this relation is a function. Coming to the second one, I will write domain. What are the domains? The x's 2, 3, 4. Excuse me. So I have taken all the x's 2, 3, 4. But the thing is, the 2 is repeating. The x, that is 2, is repeating. That means it is not a function. Okay, the third relation. First I will write domain. All the x's. 1, 2, 3, 4, 5, 6. So the first condition, I have taken all the x's from the domain. 1, 2, 3, 4, 5, 6. All the elements of the domain I have taken. And the second condition is no x is repeating. That is why I can say this third relation is a function. So you must know which relation is a function, which relation is not a function. Now suppose if a function has real number as the domain. Domain is real number. Codomain can be anything. I'm not talking about the codomain. If domain is a real number, then I can say it's a function. It's okay. But here, the main point you have to think is what will happen if codomain is a real number, or if codomain is a subset of real number. That's the main thing you have to notice. The codomain, which I'm talking about, codomain is either real number or subset of real number set. Either real numbers or subset of real numbers. Then you can say it is a real valued function. But suppose in a function, if both domain and codomain are either set of real numbers, both of them, or subset of real numbers, then you can say it is a real function. That's the difference between these two. Let's go to another example. N is the set of natural numbers. A real valued function is defined as from n to n. And then y is given as 2x plus 1. Using this definition, complete the table. So there is a table given. Like x values are given as 1, 2, 3, 4, 5, 6, 7. Y values you don't know, you have to finish. So how will you get y? You will take the equation given. This is an equation. In this equation, you will put x as 1. Then y will be 3. When x is 2, y is 5. When x is 3, y is 7. When x is 4, y is 9. When x is 5, y is 11. When x is 6, y is 13. When x is 7, y is 15. So in all the cases, what is happening? X is very, very important, because only if you put x in the equation, then only you will get y. If you don't know what is x, you don't know what is y. So put x, get y. That means we get y because of x. Y is obtained because of x. That means y is dependent on x. Completely dependent on x. If there is x, there is y. If there is no x, no y. So y is function of x. Y is f of x. Y is nothing but f of x. So this equation y equal to 2x plus 1, I can also write f of x equal to 2x plus 1, because f of x is nothing but y only. Y is function of x. So every equation, sometimes if there is an equation, I will write y equal to 2x plus 1. Sometimes I will write f of x equal to 2x plus 1. You must not get confused. Okay, so I will fill the table. Y is 3, y is 5, 7, 9, 11, 13 and 15 based on values of x. So this is how I'm getting the function. Okay, now I will tell you some important functions and their graphs. Maybe we will not be able to complete full, but at least a little we will do. Some important functions or equations. Now functions means f of x, or functions means y, or functions means equations, not all equations. So we will take functions and their graphs, some functions. First one is identity function. What do you mean by identity function? Identity function means y will be equal to x. Both are same. Identity means same. Y and x will be same. Or f of x equal to x. That is identity function. So when I want to draw a graph, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. Like that we will have. So when you draw the graph, how will you take? 1, 1, 2, 2, 3, 3, 4, 4, 0, 0, minus 1, minus 1, minus 2, minus 2, minus 3, minus 3, minus 4, minus 4. Like that you will take. All such points we will take and plot on the graph. So not only this, it will continue. If you draw a line, I will use a different color so that you can recognize. So I will join all the points, not only these points, the line will go further up and further down. So this is the graph of the function x. Now in this, how to find, this is called identity function. And identity function, we will write from set of real numbers to set of real numbers. You can see domain is set of real numbers. Codomain is set of real numbers. And range also real numbers, because a range will be either equal to codomain or range will be subset of codomain, right? So range also will be set of real numbers only. From this graph, that is what you can see. Coming to the second function. Second function is a constant function. Constant function means the function will be equal to some constant. C is nothing but a constant. Constant means any number. So this function is also from real numbers to real numbers. Okay. When I take this function, y is always c. F of x means y. So y is always c. Y is always the number c. X can be anything. X can be 1, X can be 2, X can be 3, but Y will be C. So if I draw the graph of such function, how will I draw? For example, Y on Y axis, Y is C here. So when X is 0, 0 comma C, 1 comma C, 2 comma C, 3 comma C, 4 comma C, minus 1 comma C, minus 2 comma C, minus 3 comma C, like that it goes on. So if you join all these points, this line will go continuously like this. So this is the graph of the function f of x equal to c, where c is a number. Now, the domain of the function is set of real numbers, But the range is only C. Of course, codomain is set of real numbers again. Why range is C? Because y is not changing. Y is remaining C. Y is means C's, nothing else. That's why. Let's go to the third graph. Third function. Third function is polynomial function. How polynomials look like? The function also looks like that. The function will be a0 plus a1x plus a2x square plus a3x cube. Like that it goes on up to an x power n. The function's domain is set of real numbers. Codomain is also set of real numbers. Of course, if codomain is set of real numbers, range also will be real numbers. Set of real numbers. Okay. What are these A0, A1, A2, AN? These all are constants. These all are numbers. And they are nothing but real numbers. All these belong to set of real numbers. So polynomial functions are of many types. Suppose if I write the function x square plus 2, this is a quadratic function. If I write the function is x plus 2, this is a linear function. If I write f of x equal to x cube plus 2, it's a cubic function. Like this, different degrees, different names are given for such functions, for polynomial functions especially. Now we will learn about polynomial functions in the next class because we don't have time to proceed for the next one. So, as I tell you in every class, be revising again and again. See you in the next class. We will end.